Okay, thank you. So, good afternoon. My name is Dr. Jabera Matogoro. So I will be teaching you this course, CT413, which is on operating system interns. And as we have already started the course in our session, so we kindly proceed on our lecture today. So, okay. As you might be aware, as I mentioned in the class, the main learning outcome for this is we are intending to give you advanced skills that can help you to understand how the core component of the Windows operating system and Microsoft servers works. So today we are going to talk a little bit about processes. I remember on the previous session, we discussed issue related to Windows API. And our last lecture was on Windows runtime. So today we are going to proceed.
Niingia kwenye nani, nataka nitoke. Jina langu lishaenda.
Yes, so we can proceed. I think there was the internet issue, so there was a disruption. So if you are not speaking, kindly mute your mic. Are you able to see the screen?
Yes.
Oh, good. So let's proceed. Okay, so today we talk a bit about the relationship between the .NET framework and the operating system. So you can see these are the interfaces connect between the .NET application with the Windows kernel. And I would also like to talk on the services, functions, and the routines. So in actual services refer to the discrete units of functionalities that can be accessed and utilized by other software components of a network. Often it's through the API, or sometimes we call the callable routines in the operating system, device drivers or service processes. So these are the way on how you can access services. And functions is always a block of code designed to perform a particular task and can be called or invoked by other parts of a program. They usually take inputs. Once they have the input, they can process the inputs, and at the end, can return an output. So I know in the class, I also asked, and some of you mentioned that you are developing application on different programming languages like C++, as well as C programming language. So this is also a way, I hope you have managed to write some few functions that can execute or run your programs. So another issue is on routines. So routines are similar to function, but often used in the context of procedural programming. So they can include functions, subroutines, or some procedures. So it's important you able to distinguish between services, functions, and the routine as they're used on Windows in terms. So another discussion is on the if you are not speaking, kindly mute mic. I can hear some people talking. Okay. Sorry, so can proceed. Okay, thank you. Yes, so in terms of native system services, or what sometimes we call system calls, these are the undocumented underlying services in the operating system, and that are callable from user modes. For example, some of the system call, we have NT create user process, which is an internal system service that the Windows create process function calls to create a new process. Another issue that I also wanted to discuss is on the related to routines. As I mentioned, these are subroutines within the Windows operating system that can be called only from kernel modes. For example, xallocate pull with tag is the routine that device drivers call to allocate memory from the Windows system heaps called pulls. And in terms of Windows services, we also have the different services. For example, you might be aware that these Windows services are process started by the Windows Service Control Manager. For example, if you have the task scheduler services runs in a user mode process that supports schedule task commands, similar to what you have in Unix, ART, and cron. So we also have the dynamic link libraries. So this is what we call the callable subroutines linked together as binary files that can be dynamically loaded by application using the subroutines. And an example of these include msvcrt.dll, DLL, which is the C learning.
Masomo tu kila mtu. Zoom meeting.
Okay, so we also have the dynamic link libraries. As I mentioned, these are the window user components and application, and they do use we do use a DLL extensively. So the advantage of the dynamic link libraries provide a user static library that of course, the advantage of dynamic link libraries provide of static libraries that application can share dynamic link library, and Windows ensure that there is only one in-memory copy of dynamic link libraries code among the application referencing it. So in terms of the .NET assemblies are always compiled as dynamic link libraries, but without any unmerged exported subroutines. So instead, we do have the CLR passes compiled metadata to access the corresponding types and members. So it's important you also be able to know. In terms of the processes, sometimes program and process may seem similar on surface, but they are fundamental difference. A program is normal, what we call a static sequence of instruction, while a process is a container for a set of resources used when executing an instance of the program. So for example, a process is an instance of program that is executing. So each process has its own memory space. And sometimes you also have system resources and execution time. Some of the key components of the process include process ID, something called the PID, which is a unique identifier for each process. And we do have memory and context. So for those who are using Windows operating system, so you can just click the Control-Alt-Delete, and then you select the task manager, and then from there, you can be able to access some of the processes that are currently executed in your computer. So, so what are the type of processes? We do have two types of process. We have user process and system processes. Example of user process include the text editor, the web browser, and many other user applications that you could have launched. But we also have system processes. These are the type of process initiated by the operating system to perform background tasks, including system daemons or services. So when you have a process, it has a life cycle. So you can create a process. A process can be created when a program is initiated, but also the process can be executed. That means when performing a certain task. And also a process could wait. So in case of maybe waiting for the resources or sharing, it could wait. But at the end, the resource can be terminated. So once the process completes, its task terminates or stopped. So these are some of the life cycle of the process. Okay, so in terms of process management, we do have scheduling. So the operating system determined the order in which the processes are executed. But in terms of the inter-process communication, which is a mechanism for processes to communicate, so okay, let me mute those. Yes, if you're not speaking, so you kindly mute your mic. Okay, so we also have in terms of process management, resource allocation. This is the operating systems normally allocate resources like CPU, memory, and input-output devices to process. So these are some of the process management, which is very important. So when I was, of course, this is something that I captured from my computer when I was preparing this session. So you can just go, as I mentioned, you can just click Control-Alt-Delete, and then you can select the Task Manager button. And from there, you could also, once you have executed the Task Manager button, you can access the list of processes. And maybe there are little you can do from this window. So in case you want to see more information, you can click the more, of course, the detail tabs, which is to also expand button and show more task manager full. So you can, of course, I have just expanded the same. So here you can see the details of various processes. So actually, you could even know this is the user process or system process, as I mentioned in the previous slide. Okay, so you could also do this in your laptop, and maybe when you are doing your revision, you could also access the same and see some of the different processes that are running on your computer. So in case you find some malicious activities or maybe a process which you might not be aware, so you can just right-click on it and you can end the process. Okay, so the detail tab always show process, but in more compact manner. It does not display windows created by the process and provides a wider variety of information. Okay, so thank you. And you could also just like click on the header row, and you could also in case you want to add more information, like you can see the publisher, the PID, the process name, the command line, the GPU engine. So all of these are the information that you can access when you right click on the header row. So in case you just want to add some more details. Okay, so some of the key columns, you could have threads, which a thread column shows the number of threads in each process. And this number should normally be at least 1. And there are no direct ways of creating processes with no threads. So if a process shows 0 thread, it usually means the process cannot be deleted for some reasons, like maybe likely due to bug driver codes. You could also have the handle columns, which display the number of handles to kernel objects opened by a thread running within the process. So these are some of the columns that you could have when you're accessing. We also have a process. You also have the status column. It can be tricky, but for a process without a user interface, running should be a normal case, even though the thread might be waiting for something. So for example, a kernel object being signaled or some input-output operation to complete. So the other option for such process is suspended, which occurs if all the threads in the process are in the suspended state. So yes, this is unlikely to happen by the process itself, but it can be achieved programmatically by calling the undocumented NT-suspend process, which is a native API on the process, typically through a tool, for example, Process Explorer or Describe Writer, such as an option. So this is some of the key columns that could find when you want to explore more on the process. I think on the reference book that I provided, you could also do some few experiments. This is Sierra. This is our first assignment. I recommend in your group try to go through the reference document, and then each group should be able to find it. You can use it, maybe a TLRist.exe tool in the debugging tool for Windows to show some of the process tree by using /t switch. So these are some of the output that you could find. So I recommend Evel group to perform this, and at the end you can submit to me. Okay, so another, I think I have also another assignment on the same. So another experiment is on viewing process details, as I mentioned. So you can view more data using the Process Explorer. So use the reference book that I have given you, and then try to do this. So these are two assignments that you can do while doing a revision, and then submit the same. Okay, so as we go through, I ought also to cover something on threads. So a thread is an entity within a process that Windows schedule for execution. So without it, the process program cannot run. Okay, so if you're not speaking, you could try it. Let me As I mentioned, if you are not speaking, kindly mute your mic to avoid background noise. Okay. Yes, so in terms of thread, as I mentioned, threads always include some of the essential components, like the content of a set of CPU registers representing the state of the process. You also do have two stacks, one of the thread to use while executing in the kernel mode, and one for executing in the user mode. The thread will also have a private storage area, which is called thread local storage, for use by subsystems, runtime libraries, and DLL. So a thread will also have some unique identifier called thread ID, which is normal used to identify each thread. And it's very important to try to check on when we are doing your revision. So in addition, a thread sometimes have their own security context, which is also important to mention, which is often used by the multi-thread server application that impersonates the security context of the client they serve. So the volatile registers, stacks, and private storage areas are called thread context, because this information is different from each machine architecture that Windows run on. So this structure by necessity is an architecture specific. So the Windows get thread context function always provide access to this architecture specific information. It's normally called the context block. So these are some of the issues that I think is important to understand. So I also thought it's important to mention that something of the execution rather than relying on the priority-based scheduling mechanism built into Windows. So fibers are often called lightweight threads. In terms of scheduling, they are invisible to the kernel because they are implemented in the user mode in kernel 32.dll. So to use fiber, first call the Windows convert threads to fiber function, which converts the thread to a running fiber. And then the newly converted fiber can then create an additional fibers via the create fiber function. So each fiber can also have its own. I begin selecting another fiber to run. When using fiber, it's generally not recommended, of course, because they are invisible to the kernel, and they also have issues such as sharing thread local storage, because several fibers can run on the same thread. So although fiber local storage exists, it does not solve all sharing issues, and input-output bound fibers will perform poor regardless. So these are some of the issues that this session we can have a discussion, and maybe I can open up for maybe a question or any comment. So we have covered what is a process in SAML, and we also gave a details related to processes, but we have also covered threads and some of the information related to threads. And final, we covered fiber. So at least for today's session, those are three main components that build a background to our next session on the Windows in 10. So I stop there. In case you have any question, you can raise up your hand and then ask, or you can comment. Okay, so maybe I don't see people speaking, so you can unmute and then speak. Or I can also ask a question. Maybe I can take this to Florence. Florence George, what have you understood on the term process as we covered in this session? Florence George, can you mute your mic and speak? Yes, Florence, kindly go ahead, unmute and speak. Florence George, if you are speaking, you are muted. We can't hear you. So kindly unmute and thank you. Generova, if you can speak, what have you understood on the thread, the term threads? Yes, thank you. Areni Mashiku, can you speak? What have you understood by maybe a term fiber as we discussed today? As usual, you can just search it or refer to the reference and then try to respond. I just want to check if we are all together. Florence, you were not able to unmute, so I think if you are speaking, we can't hear you.
It's me.
Yes, Florence, so now we can hear you. You can speak. Thank
Okay. You were asked about the process.
you. Yes, thank you.
For my understanding that you have read, process refer to the instance of running programs, whereby each process contains the program's code and the current activity, including allocation, memory, threads, and the system resources.
Thank you so much. You have explained it very well. So this is a way showing that we are all together. Nema Royce, I'm not sure if you can speak. I just want you to speak on what have you understood on the term fiber as we covered in this session. Thank you, Florence. George, it was good you able to explain process, and I hope when you are doing your personal revision, you will be able to get it very well. And I'll also share the presentation and the recording just for review. Okay, thank you so much. If there is no any other comments, we can end up here, and then I will share the recording and also share the slide. Thank you so much. Have a nice day. Thank you. Bye.
Thank you, sir.